This is lesson 23. Today we're going to learn about prime factorization. Go ahead and push pause, write the title down, and push play when you're ready to begin. Alright, so prime and composite, what is that? Let's talk about prime numbers and composite numbers and what's the difference between them. So we've got prime, which I call the loners, and composite. Those are the popular numbers. They have friends. What this means is we're talking about their factors, the numbers that you put together to build these numbers. So for the number, well, I don't want to use number 1. Let's go with the number 2. What factors can I use to build the number 2? Factors being numbers I multiply together. Well, the only numbers I can multiply together to make a 2 is 1 times 2. That's it. There's no other way to get 2. So he is a prime number because his only factors are a 1 and himself. He's got no other pair of friends. Let's look at the number 3. The only way I can get 3 is by multiplying 1 times 3. No other way to do it, so he would be a prime number because 1 times 3 is the only way to create him in multiplication. Let's look at a 4. Well, I could do 1 times 4 to get 4, but I can also do 2 times 2 and get 4. So that number has other friends. It has 2 times 2 also. So we call 4 a composite number. So 4 is composite. 5. The only way to get a 5 is 1 times 5. So that makes 5 prime. 6. Let's look at 6. 1 times 6 will give you 6, but so will 2 times 3. So he has some friends, so 6 is composite. And so you can go on and on. Any number that is a loner that only has 1 times himself only is prime. Any number that has 1 times himself and other friends is composite. So I just went ahead and cleaned up the definition a little bit, and go ahead and write this definition to your notes. Prime numbers are the numbers only factors are 1 times himself. Composite numbers can have other factors that create it. And we'll make a quick list of prime and composite, starting with the number 2. 2 is prime because only 1 times 2. 3 is prime because only 1 times 3 create it. 4 is composite. Make sure you're copying these down as well, because 2 times 2 can make 4. So 1 times 4 and 2 times 2 makes it composite. 5, only 1 times 5 makes him prime. 6, 1 times 6 and 2 times 3, he's got some other friends, he's composite. 7, only 1 times 7 makes 7, he's prime. 8, 1 times 8 makes 8, but also 2 times 4 makes 8. He's got other friends, he's composite. 9, 1 times 9 and 3 times 3, composite. 10, 1 times 10 and 2 times 5, composite. 11, just 1 times 11, prime. 12, 1 times 12 and 2 times 6. Actually, every even number after 2 ends up being composite because 2 can divide evenly into it. 13, just 1 times 13, that's prime. 14, 2 times 7, it's composite. 15, 3 times 5, composite. 16, 4 times 4, composite. 17, prime, only 1 times 17. 18, 2 times 9, composite. And 19, prime. And what I want you to do, you've copied that down with me, and what I want you to do is go ahead and circle your primes. 2, 3, 5, 7, 11, 13, 17, 19. There's more. If you keep counting up, you're going to stumble across more primes. Fewer and further between. But these are the prime numbers between 1 and 20. So why is it important to learn about primes? Well, we're going into learning about prime factorization. And the prime factorization is a tool that will become helpful for us learning how to break down the numbers. Helps us when we go into working with fractions, GCD, LCM, fraction work. Knowing how those numbers break down is helpful. So I'm going to show you today prime factorization to kind of help your brain with things later on. So we're doing prime factorization. Looks confusing at first, but actually it's fairly easy. We're just going to find out, let's do an I do. We're just going to find out what prime numbers would I need to multiply together to get 32, or whatever number we throw out there. In this case for the I do, 32. So I'm going to say, oh, what's the prime factors of 32? And I like to use the Christmas tree approach. So that's like the star on the top of my Christmas tree. And I can ask myself, I wonder what numbers I can multiply together to get 32. Well, the first thing I'm going to notice is that's an even number. Any number that ends in 0, 2, 4, 6, or 8 is an even number. And 2 divides evenly into any one of those numbers. So I know 2 times something will give me 32. That's a times. Times. There. I'm not sure what, so the reverse of multiplication is division, so I'm just going to figure it out real quick. 2 fits into 3 once, and 2 fits into 12 6 times. Oh, so it's 16. So you could really quickly figure that out. And then I keep branching out my Christmas tree. Well, in this case, 2 is a prime number. If we look at our list in our notes, we see that 2 is a prime number. So circle your primes. Those are like the ornaments on the Christmas tree, prime numbers. But I can branch out 16 because 16 is composite. And so I can break it down into another set of numbers. 4 times 4 makes 16. Or 2 times 8. I could have used that too. That's fine too. And then I'm going to look at 4. Is 4 prime or composite? It's composite because 2 times 2 is 4. Prime, ornament, prime, ornament. And over here, branch it out because 2 times 2 is 4. Prime, prime. So if I multiply 2 times itself, 1, 2, 3, 4, 5 times, 2 to the 5th power, 2 times itself 5 times, then I would get 32. So these are the prime factors of 32. Over here, I just want to show you something real quick. If I'd done the 8 times 4, some of you might have said, oh, 8 times 4 is 32, Mrs. Sanchez, don't you know? So 8 times 4. If I had done that, I would have looked at 8 and branched it out and said, that's 2 times 4, prime. That's 2 times 2, prime, prime. And this is 2 times 2, prime, prime. That's 2 times itself, 1, 2, 3, 4, 5 times. 5 times. And I still would have gotten the same answer. So there could be different approaches to get there, but you'll end up getting down to the same primes as you get down there. So let's do a redo. Go ahead and copy down the number 45. And we're going to do the prime factorization of 45 using the factor tree. So 45, it ends in a 5, and when numbers end in a 5, then or 0, 5 divides evenly into both of them. So into it, the number. So 5 times what will give me 45. Well, it's 5 times 9. Again, this is a skill where having your math facts memorized is really, really important. So if you have not yet memorized them, I've warned you that this is something that's going to continue happening. You definitely want to put extra time into memorizing your math facts. Okay, so 5 times 9 equals 45. And if you look at your list on your notes of prime factors, 5 is prime. But 9 is not. 9 is composite. And that's because 3 times 3 equals 9. 3 is prime, and 3 is prime. So the prime factors of 45 is 3 times itself 2 times, so 3 to the second, times 5 times itself 1 time. So these are the prime factors of 45. I'd like to do another a we do too, with a larger number. So let's look at the number 150. And so we want the prime factorization of 150. And I always try and find the largest number I know will divide into that number equally, because remember, division is the reverse of multiply. So if this is a number divides into this, it's multiplied by a certain number. So when I see zeros on the end of numbers, I think, oh, 10 times something. So 10 times 15, because you just take that 0 off, right, would give me 150. Now I've got much smaller numbers to work with, so my brain knows these math facts. 10, the factors of 10 other than 1 and himself would be 2 times 5. 2 is prime, ornament. 5 is prime, Christmas ornament. 15 is composite because other than 1 times 15, there are another set of numbers that will multiply together to give me that, and that set of numbers is 3 times 5. 3 is prime, and 5 is prime. So my prime factors of 150 is 2 times 3 times 5, but there's 2 of those guys, 1, 2, so 5 to the second. And that is the answer for the prime factorization of 150. Okay, you've seen a couple of examples. You might have rewinded to kind of hear it through a couple more times. Now it's your turn to try it. See how you do. You might get stuck, that's okay. You just push the play button and have me catch up with you. Try to find the prime factors of 28. Push pause and try it, and then push play when you have an answer or when you get stuck. Alright, so let's see how you did. I'm looking for the prime factorization of 28. Well, let's see. And there's a couple of different ways you might have done this. So I'll do it kind of 2 ways, and you can see that they would both have worked. I don't want you to think you were wrong right off the bat. In my brain, because I know my math facts very well, when I see the number 28, I think 7 times 4, because 7 times 4 is 28. But maybe that's not what your brain thought. Maybe your brain said, hey, that's an even number, so 2 divides into it evenly. And 2 times, I don't know, let me do this little shortcut real quick. 2 into 2 is 1. 2 into 8 is 4. Oh, okay, so it's 2 times 14 is 28. That's true too. All right. If you did the 7 times 4 route, you would have seen that 7 is on that list of primes, so there's your first prime number, your first ornament. But 4 is not prime because 2 times 2 equals 4. Prime, prime. So I have 2 times itself, 1, 2 times 7 is the prime factors of 28. Well, if you took this route over here, let's see if you'd end up with the same thing. You have 2 that's prime, and then 14 is a composite number because 2 times 7 will make that 14. 2 is prime, 7 is prime. That's 2 times itself, 1, 2 times, and then 7 times 7. Same answer. Even though we took a different starting route, it brings us down to the same every time. It will do that. So hopefully this is making sense to you. If you're ready for your closure questions, come see me. If you are not quite sure and want to rewind and hear a couple of the practice ones again, you can do that. Or if you want me to explain in person, you can do that as well. Come see me about it.